Yeah, okay, so you have 15 minutes.
Okay, thank you. And the application studies of IoT device for landslide monitoring. This is a presentation about these studies inside our InterSCity project. And the outline for this presentation to explain exactly what is landslide, to understand the phenomenon, and the experimental phases and application studies used for that. The first one, the landslide, the specific kind of the landslide is shallow. To explain this is mostly the video, for example, in the rain. For example, we have a specific mountain on slope and the dies in the rocks and so on. And the rain to put water penetrating the soil and the soaks, and the downforce to provoke the landslide. Is this the main causes from the landslide in Brazil, in the Latin America, for example, and have several problems in the houses and the human ocean, so about that and so on. And about sensors to use for that in landslide monitoring, and the working from the Denise, the other member from the InterSCity. The main sensor for that is used accelerometers, inertial sensors, inertial meters, to identify vibration, movement, and similar aspects of that. So unfortunately, the base of inertial data is not common to find about the experimentation in landslide phenomenon. So idea is to create a base for initial data about this phenomenon to understand how to possible to monitor landslides using low-cost sensors or inertial sensors like accelerometer. For this, use 3 phases in the laboratory test, and the other in different scale, and the dump trunk. In real slope, the others are in real environment to monitor this environment. The phase 1 in laboratory to use a specific machine for that is around 1-2 meters in dimension. You put exactly sand inside of this machine into different movements to simulate in landslide. Put the sensors inside of this machine and to recognize the signals for that. This case is inside of the master degree thesis from the Unicamp in geology, using this environment together, IPT and InterSCity members, researchers, and to possible to notice, identify variation and different patterns before landslide. Of course, during the landslide, it's possible to see several movements. However, the interesting is to see before landslide. It's possible to recognize patterns for that. In this environment, in this lab, it's possible to identify something, but you need to more experiments in long term to understand the real cases in other scenarios. So, and to go to second phase, for example, use inside of the dump trunk, you have now to show the data from the 2 experiments in this environment. We use 5 sensors and 2 kinds of sensors, one ESP32 using inertial sensors, and the other manufacturer about what's the most use also inertial sensor to put in different parts of the dump truck. And to see data, for example, it's more simple to see the video. I look at it, I hope it's possible to see something now. Don't have a song about that, but I explain something. For example, and you put in here the signals from the sensor, in the lateral view, in the back view of the movement from the sand in the trunk. And the idea is to recognize patterns before the landslide to understand what happened in this moment. For example, and when to see specific slope or specific movements, the signals probably some signals, and spots to see now. For example, now it's probably to see specific movements for the landslide happening, but the most important of that, of course, is before the landslide to recognize different patterns about that. For example, now to recognize specific moments of the landslide happen. of course, the idea is to identify the other movements about that. Return for presentation. And for example, we have a specific sensors and the views about that, views about the lateral view and the back view, and the position of the sensor inside of the dump trunk. These signals in data are sent for the InterSCity platform and collect this data and put in data lake to recognize the movements and so on. And in this one, it's possible to see the graph from the signals, for example, in the first test, and put the sensors in the back part of the trunk. And it's possible to note, of course, before different behavior about the signal is to see exactly point of the complex flow. But in this experiment, it's good to note in specific movements. For example, in this signal, the dark color here, these sensors don't fall from the dump trunk. The earth falls to the floor. But when you return the original position, the sensors continue inside of the dump trunk. And it's possible to notice in the final acceleration, the value is very similar to original position, but different, small difference about the original point and the final point when to dump trunk return your original position. It's a good to note because it's possible to identify and have a specific movement, but after that, it's possible to recognize how to movement in the soil after some specific movement in the soil. For example, in second test, putting the sensor in different locals inside of the trunk, it's possible to notice specific movement. For example, in the two sensors, in sensor 4 and sensor 2, have a specific movement, and sensor 3 and sensor 1 have other movement, and the complete flow, of course, the signs is very similar in this environment. About results and the fight about that, about online submission of our channel is not practical for that because the consuming of the energy, the data volume, the long-term monitoring is not possible. Two is need to recognize patterns and use a specific strategy to send signals in specific moments. The other find, for example, is device works like an inclinometer to notice a specific movement after a long time of experiment. It's possible to compare the original position from sensor after a long time to compare with the original position of this sensor. The other aspect is good to note is about sampling. This sampling should vary according to vibration lab. Of course, you have a specific vibration lab to increase the sum, or when nothing happens, you stop the sampling about this information. So, for example, other characteristics for that, for example, use hibernate and wake up, depend of the vibration state start for that. Of course, you look at just one sensor, it's more important to look at the group of the sensors, because one sensor have a specific problem, but the other sensors in the same area could see different information. This information all together may be good information about landslide environment or landslide phenomenon. And the final about recommendation and conclusion about these phases, for example, you need to assess the stability of the long-term sensor because the water thickness, influence of temperature, vibration, or other effects about disturbance. For example, you have a specific trunk running close to slopes, probably have a specific movement, vibration, behavior about that. You need to recognize is good or not about this disturbance. Sensors nodes should have a mechanism for data buffering and processing to permit a low unnecessary data elimination, because many times, because the phenomenon is not fast, it's very slowly phenomenal. So several times don't have nothing. And this case is a good idea to use machine learning, for example, to recognize the signals. In specific environment from the fog or edge computing to analyze the group of the sensors, analyzing different signals for that. In the first one, about the phase 3, is this moment we are in the phase 3, and to put specific sensors validating the lab phase and the thumb trunk phase, it should deploy and test in calibration phases in Guarujá cities, the city from the close to sea here in São Paulo. And the data is stored from the rainy season in the final of this year and the start of the next year. And after that, to do a data analysis from different partners in InterSCity projects, for example. And to finish, thank you, and open to the question. Thank you.
Okay, thanks, Alessandro. I'll start with a question, but if people have more questions, please type in the chat. Very nice, the experimental environment that you set up with that truck, but I think it looks a bit very unrealistic. In particular, what you, from the video you showed, you don't see almost any movement, and then like 1 second before the landslide, you detect a lot of movement, but 1 second is not enough in advance, right? So I wonder if there's, and in the first figure you showed a different scenario in which you have a mountain, a slope of the mountain with trees, and then it rains, and the rain causes the landslide. I wonder if you could try to build in the laboratory something closer to that. It would need to be a more irregular landscape, maybe with some trees on dirt, and then you would put water in a controlled way and measure if they're probably with more sensors, more than 5, maybe with 50 or 100 sensors. That maybe could be, maybe you could feel movements in the land before the final moment of the landslide. So have you thought of doing that?
Yes. Unfortunately, in this presentation, I don't put the other sensors for that. Now, of course, I use sensor for humidity about the level of the water inside of the soil. Use the correlation about the level of the humidity in the soil, and comparison about the vibration starts with, in the first phase is happens. The second phase also, of course, in the final phases, in the real slope, the accelerometers inside of the soil, but have other sensors in the same area, look at, for example, level of the rain and the level of the humidity inside of the soil. So we have many information about that. Of course, in the phase 1 and phase 2 lab tests, complete accelerated movement. It's not complete real scenario. So the data from the real scenario in Guarujá is a good idea to accumulate the data. You understand the real environment, look at the sensor from the... I
have a question about this. In this real scenario in Guarujá, will you just put the sensors there and happen for something to happen, or you will actively make some changes in the soil to make a landslide to happen? Will you create a landslide there or not?
No, create a landslide, because it's not so simple create a landslide in this environment.
I know, but yeah. But okay, I think you must do it, but I'm afraid that you just find out that nothing happens.
Exactly. This is a big problem for that. But in this environment in Guarujá, is geologists to identify, because landslide is happening in this moment, in this area, because this movement is very long. But I recognize a specific local for that, because in this local, landslide is happening. I don't know, it's completely full, but it's slowly full movement in this area, because this, I put the sensors in this area.
Okay, so hopefully you can detect it. Okay, thanks. Any other question? Guess not. Thank you very much, Alessandro. for nice work. Hope to see new results next year.
Okay, thank you.
Now